Hello, everyone. Welcome back to this live series on data science with Python by PamTen. So, in our previous session, we learned about Python basics, and in today's session, we'll start off and do some problem solving. So, let me just see if we're actually live on YouTube and if you guys have any questions. Right, so seems that we are live, and if you have any questions, you can keep posting them in the chat, and I will keep checking them and I will respond to them promptly. So, in this particular session, we'll tackle some really common problems, and then these can be solved with any programming language. But since we are covering this entire data science series with Python, we'll be solving all of these problems with Python. So we shall cover how to perform linear search, and then we'll see how can we find out the largest element in an array. And there's a very common problem called as longest common prefix. And then similarly, we'll have to find out if a number is a palindrome or not. And then there's another very common example or a problem, which is finding out the majority element in a array of numbers. So we'll be solving all of these today. So let's head to Google Colab and solve these. So this is my Google Colab. So for all of those people who would have attended the previous session, you would know what Google Colab is, and all of you know how to open Google Colab and start executing your Python code over here. So our first problem was on linear search. So what exactly is linear search? Well, this is a very common algorithm, and this helps us in finding out one particular element or one particular item from a series of values which are present in an array. So I'll just go ahead and create an array over here. I'll give this a name of ARR, and I'll give in here some numbers. So I'll store the values 10, 20, 30, 40, and 50. So what I've done over here is, so this basically my array, and I'm creating this using our list data structure in Python. So again, for students or for attendees who would have watched the previous lecture, you would have known what a list is and how can we create a list in Python. So this is how we have created a list. Now, what I want to do is, if maybe the user gives me, tells me, where is the number 30 present in this array, then I'd have to return him the index value of that particular element. Let's say if you'd want to find out the position of this number 50, this would be present at index 0, 1, 2, 3, and 4. Similarly, this number 10 is present at index 0. So that is what we'll be doing in today's session. So for this, we'll be using something called as a function. So till now, we haven't worked with functions or methods. So if we have to create a function, we can use something called as def. So def is a keyword in Python, which helps us to create definition or a method or a function. So you can call it whatever you want. Now I will give this a name of len search because we are performing linear search. So this is how you create a method. So you give in the keyword def, and then you give in the name of the method. So you can give in whatever name you want. This is, you can consider this as a variable. So you can just give in whatever name you want. And inside this will take in something called as a parameter. So since I've not given anything over here, this will just take some time because I've just instantiated this notebook, and also this is incomplete over here. So as I've said, this will take in some parameters. The first parameter would be an array, and then the second parameter would be the target for which I'd have to return the index. So I've passed these two as the parameters inside this. Now what I want to do is, if given an element, I would want to return the index. So I will go ahead and create a for loop. So for I in, I'll have length of, this will actually be range of length of array. And what is basically happening over here is this I will go through all of the elements which are present in this array. So here length of array basically means that the length of array is 1, 2, 3, 4, and 5. So this range will go from 0 to 4. So I will have the values of 0, 1, 2, 3, and 4. Now that we know what is stored in I, we'll just go ahead and check for each element if this is what the user actually wants or not. I will give in the if condition over here and check if array of I is equal to target. So if that is actually the case, then I shall go ahead and return that particular index. So index over here is I, and if actually we given a value such as maybe 500 or -5, so if we given an element which is not present in the array, I'd have to return -1. So what I'll do is, if none of this is executed, or if this particular piece of code is unable to find the value, find the target, then we shall just go ahead and return -1. So this is my method over here, len search. Now I shall go ahead and call this. So this is called as function definition, where we are creating this method. Once we have created the method, we can go ahead and call it. Again, since this takes in two parameters, the first parameter is the array, which we have created over here, and then I can give in a target value. So now, if I want to find out where is number 50 present, I can just give in the value 50 over here, and you shall see that number 50 is present at index number 4. Similarly, if I want to see where number 10 is present, here you shall see that number 10 is present at index number 0. If I give in a random value, let's say if I give this a value of 100, you shall get -1. Similarly, if I give this -100, again you shall get a value of -1. So let's go through this code again. Here, this for loop goes through 0 to 4. So I has the value of 0, 1, 2, 3, and 4. And for each of the element, we are checking if this is equal to the target or not. So now I will change this to 50 again, and we'll understand this properly. So here first we shall check if array of 0, the element which is present at 0th index, is it equal to target. So is 10 equal to 50? No. Again, I is incremented, I becomes 1. So here array of 1, which is 20. So is 20 equal to 50? No. Then we check if 30 is equal to 50. No. Then is 40 equal to 50? No. And then we finally reach here, which is 50. And then we check if 50 equals 50. Here, this is evaluated to true. Array of I is equal to target. And since that returns true, we go ahead and return the index value. So index is 4 over here, and that is what we get. So let me go ahead and execute this. So as you guys see, we have successfully created this method which would help us to find a target value from an array of numbers. So this was our first problem where we went ahead and learned how to do linear search. So I'll just go ahead and add in a comment over here for linear search. Now, once linear search is done, we can go ahead and try to find out the maximum element which is present inside an array. So here I shall write another name, max element in array. Similarly, I'll go ahead and create another array over here. I'll give in random values. So I'll give in 4, 2, 1, 5, and 3. So out of all of these values, I need to find out the maximum element. So what would be the logic for this? Well, we can just to keep traversing through this entire array and have a variable max, and then keep comparing if that is equal to the max value or not. So what we can do is initially will initialize a variable called as maxi to the lowest possible value. We'll store it in maybe minus infinity. So we have minus infinity stored in maxi, and once that is done, what we shall do is if this is greater than maxi, then replace it with maxi. Was 4 greater than maxi? Well, replace it. Then since maxi becomes 4, we go ahead and check if 2 is greater than 4. Is 2 greater than 4? No. Go ahead. Is 1 greater than 4? No. Now we come over here, and here we check if 5 is greater than 4. Since 5 is greater than 4, we go ahead and replace 4 with 5. Then again we have another element left, which is 3. So this time we check if 3 is greater than 5. Is 3 greater than 5? No, that evaluates to false. And then finally we have 5 stored in maxi, and that is what we return. So let's go ahead and also create a method for this. I'll call this max element. Again, this would take in one parameter, which would be the array itself. And inside this, I'll have one variable called as maxi. And here we have this float method, and inside float, if I want to initialize this a minus infinity value, I can do something like this. So float of inside single quotes, I'll type in minus inf, which will basically assign minus infinity value or the lowest possible value to this maxi variable. Now that this is done, what I can do is I can iterate through this array. So for I in range of length of array. So I'm traversing through this array and I have to keep checking if each element is greater than this. So here what I have to do is if array of I is greater than maxi, then what I have to do is I can store this value into maxi. And then finally, what we can do is we can go ahead and return the value. Let's see if this works properly. So now I shall call this method max element and I shall pass in my array inside this, and let's see what would be the result. So here you shall see that I have the value 5. Let's go ahead and add 6 over here and see if this works properly. Here again you shall see that I have 6. Let's maybe add 7 over here at the first position. Let's execute this again, and this time you shall see that I have the maximum value, which is 7. So let's go through the code again. Here we have this for loop which goes through all of the elements in this array, and we keep comparing those values with this. Let me remove this from here. And initially what happens over here is if array of I is greater than maxi. Initially in maxi we have minus infinity. So we check if 4 is greater than minus infinity. Yes, since 4 is greater than minus infinity, we store the value of 4 into maxi. Then again, we go to 2. Then we check if 2 is greater than 4. That is false. Then we check if 1 is greater than false. That is false again. Then we check if 5 is greater than 4. Since 5 is greater than 4, we store 5 into maxi. Then we compare if 3 is greater than 5. That evaluates to false. And finally, we compare if 6 is greater than 5. Since that is true, 6 is stored into maxi, and that is what we return. Let me execute this for you guys again, and you shall see that we have successfully got the result. So these were two problems which we have successfully implemented. Now let's see what were the other problems. So we have longest common prefix. So for this, what I'll do is I'll go to Lead Code. So this is a platform where you can solve a lot of questions. And one such problem is, what was the question? So that was longest common prefix. Let me just type in the name of the question over here. So I have longest common prefix. Let me open this up and let's solve this here in Lead Code. Let's understand the question first over here. So what we need to do is we need to write a function to find the longest common prefix amongst an array of strings. If there is no common prefix, return an empty string. So here we have this array, and this is basically an array of strings or array of words. So the first word is flower, the second word is flow, and the third word is flight. Here you shall see that the longest common prefix for these three words is FL. So FL is common for these three words. Then let's take this particular array. So in this particular array, you see that there is no common prefix. So here, dog starts with a D, race car starts with an R, car starts with a C. There is no common prefix, and that is why we return an empty string. So now, what is the logic behind this? Well, what you can do is you can think of it as a dictionary of words. So what exactly is a dictionary of words? So when you open up a dictionary, all of the words are sorted in lexicographic order. When I say lexicographic order, it is basically alphabetical. So here, let's say you have maybe so basically words start with AB and then you have AC and then you have AD and so on. So what we have to do is first we have to sort this array so that the words are in lexicographical order, and then we can compare the first word and the last word, because the first word and the last word will give us the common elements which are present for the entire array. I'll write the code and I'll keep explaining what is the logic behind this. So I have this array of strings which is strs. So now my first task would be to sort this out. So strs, I have a method called as sort and I shall invoke it. So strs dot sort, and the shall sort my array over here. So here initially I have flower, flow, and flight. Now when I sort this, this becomes flow, flower, and flight. The sort basically it puts this into a lexicographical order. So the first word is flow, second word will become flower, and the third word will become flight. So now that the sorting is done, what I have to do is I have to extract the first element and the last element. The first element, well, if you attended the last class, you would know how we can do that. So I'll just create a variable called as first, and inside this, if I want to extract the first element, so this is my array strs, so I can extract the first element by using the index 0. Similarly, if I want to extract the last element, I can do that by using the index -1. So I've stored the first element in this first variable. Similarly, I've stored the last element inside this last variable. Now that is done, what I can do is I can basically iterate through the first or the last word and then keep checking what are the common elements between the first word and the last word. So here I can basically do if, do I need an if? So I have extracted these two. Let's actually think of the logic here. So if first, I don't think we'll need a first over here. So what we can do is while we have first and then we have last. So while first, I'll just add here. Okay, so what we can do is we can actually have a for loop here. So I'll have for I in range of length of first. So I would want to iterate through this word first, and here I would want to keep checking if first of I is equal to last of I. So what happens here is first is I'll have flow and I'll iterate through the word flow, and I'll compare flow with flight because the word flow is stored in first, the word flight is stored in last, and I will check if F is equal to F, L is equal to L, O is equal to O, O is equal to I, W is equal to G. So for this, I would also need another string. So I'll call this as result, and I'll just give this a null string over here. So if first is equal to last, what I can do is I can add this or append this value to this result string. So I'll just say result is equal to result plus first of I. So what I'm doing is I'll compare this and this. So if F is equal to F, I'll add that particular element, which is F, into this resultant string. Then again, I'll come over here, I'll compare L and L. Since L and L are equal, I'll add L into this. So my result has FL. Then I'll compare O and I. O and I are not equal. So this evaluates to false. So since this evaluates to false, what I can do is, if this is true, I have added F and L. Else, if this evaluates to false, what I can do is I can just break out from this loop and I'll just have F and L stored inside this, and finally I will return the resultant string. So return result. Let's run this and see if all the test cases pass. You see that here this test case has passed, and you shall see that the expected output is FL, and that is what we've got. Similarly here, there is no common element for these three, and that is what we've returned. Let's also submit the solution and check if this executes properly. Here again, you shall see that we have been able to successfully submit this, and we have solved the problem. So this was another such problem which we've solved. Let's see what is the next one. So next we have to work with a palindrome number. So here we are basically trying to see if a number is a palindrome or not. Let me go ahead and duplicate this. Let me open up the problems tab. I'll go ahead and search for the question. So this is our question. Right, so let's look at the description here. Given an integer x, return true if x is a palindrome and false otherwise. And now we've understood that if it is a string, we can extract each element using indexing. But can we really do that for numbers? Well, that will be a bit difficult. So what we shall do is, first we shall convert this number into a string, and we shall travel from left and right and keep comparing the leftmost element and the rightmost element. So palindrome is basically a number which reads the same from left and right. So here, if you look at this definition, an integer is a palindrome when it reads the same forward and backward. So here, for example, 121 is a palindrome while 123 is not. So now here, what I can do is, so for my first task, it would be I can convert this x into a string. So I'll have y is equal to sorted of x. So we have two methods over here, sort and sorted. So sort is a method which directly converts the element or directly sorts the number, but you cannot really store it into another value. When you use sorted, you're basically storing a copy of this into another value. So x will remain the same, but you're storing its copy in y. So y is equal to sorted of x. So actually, instead of sorted, we are supposed to use string. Since we are supposed to convert this into a string, so y is equal to str of x. So here we have stored this value. And now what I can do is I can basically have two variables. I'll have L, so you can call these as pointers. So I'll have the first pointer pointing at the leftmost element, and the index of the leftmost element is 0. Then we have R, and I'll set this as length of x minus 1. So this particular pointer R will point to the rightmost element. So here the length would be 3 and the index would be 2. So that is why I've written length of x minus 1. So 3 minus 1 would be 2 and R would be pointing to here. So I have these two pointers L and R, and I'll have a while loop over here. While L is less than or equal to R. That is, till these two pointers do not meet, what I can do is I can keep comparing these two elements. So here I have to compare. So my variable is y because I have converted this number into a string and stored that string into y. So y of L, so while L is less than or equal to R, y of L. So here what we can do is we can basically use if condition over here if y of L is not equal to y of R. So what we are doing is we're basically comparing this element and this element. So if 1 is not equal to 1, we can directly go ahead and return false. Right? So if this were maybe 1 and this were 3, I can directly go ahead and return false. Now, instead of that, so if both of these were same, what I can do is I can just go ahead and increment these values. So I'll increment the left pointer by 1 and I will decrement the right pointer by 1. So L equals L plus 1 and R equals R minus 1. Now I can just go ahead and return true. So if anywhere, if this case, if wherever, if we do not see that both of these are not the same, then we can return false. Else we can just go ahead and return true because the left and right pointer are matching, which would mean that if we are going from front to back and comparing the numbers, both of them are same and it reads the same from front as well as back. Let me run this and see if this executes properly. Int has no length. So here we need to give y. Let's run this. And you see that all of our test cases have been passed successfully. So 1 to 1 output is true, expected is true, minus 1 to 1, because here when you compare minus, you don't have minus on this side. And then 10, obviously 1 is not the same as 0. Let's go ahead and submit this now and see if this gets accepted and all the test cases are solved. Yes. So we see that the solution has been accepted and all the test cases have been accepted. So this was another problem which we have solved. Let's go ahead and see what is the next problem. So we have another problem called as majority element. Now we'll go ahead and solve that. So friends, if you have any questions, you can keep posting them in the chat section. I'll take them up. So our next question was majority element. This is the question. Let's understand this. So here again, we have been given an array. So given an array nums of size n, return the majority element. And what exactly is a majority element? The majority element is the element that appears more than n by 2 times. That is, any element which appears more than half of the length of the array. So here the length of the array is 3 and something which appears more than one time. So here n by 2 you will get an integer value. So anything that appears more than once would be your majority element. Similarly here 1, 2, 3, 4, 5, 6, 7. So 7 by 2 will be 3. Anything that appears 4 times will be your majority element. And here you have in the description which states that you may assume that the majority element always exists in the array. So there is definitely one element which whose frequency is more than half of the length of the array. So for this, we'll use a data structure which we learned yesterday called as a dictionary. Now what happens is when we store these values in a dictionary, we'll get those counts, and with the help of those counts, we can easily understand which element is occurring more than half of the frequency. I'll create the dictionary. I'll give it a name of store. So this is how you create a dictionary. I've just created an empty dictionary over here. Now, once that is done, what I can do is I can go ahead and store all of these values inside the dictionary. So for I in nums, for each element in this nums array. So the name of the array is nums. Each element in this nums array, what I can do is I can keep storing the values. So store of I. So store of I, so basically nums, you have 3, 2, and 3. Initially, the value in I would be 3. So for store of 3, 3 would be your key over here. And for dictionary, you have a method called as get. Now store.get I comma 0. What is happening over here? So I comma 0, basically I am checking with this get method if this element is already present in the dictionary or not. So initially this number 3 is not present in the dictionary, and if it is not present in the dictionary, I will give it a default value of 0 and I shall increment it by 1. So this is how I am adding the frequency to it. So initially, I will go through this nums array. So the value is 3. I'll check in the dictionary if 3 is present. Since it is not present, I will add 3 and I'll give it a value of 1. Next, I is 2. Is 2 present? No, 2 is not present in the dictionary. Again, I'll get a default value of 0. I'll add 1 to it and the frequency of 2 becomes 1. Now I'll encounter 3. So this time when I check in this store dictionary, is 3 already present? Yes, it is present. So instead of getting 0, I'll get the initial value, which is 1. So till here, 3 was present once and the value was 1. And I'm incrementing that value by 1 again. So the value of 3 becomes. So what you basically have is you have key value pairs. So for 3, you have something called as 2. So for the key 3, you have value 2. And similarly, for the key 2, you have value 1. That is what we have accomplished through this piece of code over here. So this for loop is done. Now that this for loop is done, what we can do is we can go through all of the keys which are present in the dictionary and check if its value occurs more than half the times. For I in store dot keys. Again, if you had attended yesterday's lecture, you would know what the keys method is used for. For I in store dot keys, what I can do is if this will be store of I is greater than length of nums by 2. If this is the case, I can just go ahead and return I. Here, So initially I'll have the key 3. So store of I will be 3. So I am checking if store of 3 is greater than length of nums by 2. So store of 3 will be 2 because 3 occurs 2 times, and I'm checking if 2 is greater than length of nums by 2. The length of nums by 2, length of nums is 3, 3 by 2 is 1. So is 2 greater than 1? Yes. Since 2 is greater than 1, the key over here, or the element to which appears more than half the times, is 3, and that is what I'm returning. So this is how we can solve this majority element problem. Let's run this and see if this passes the test cases. And here again, we have seen that both of these test cases have been accepted. So for this 3 to 3, the output is 3 and the expected value is 3. Similarly, for this array, output is 2, expected is also 2. Let me go ahead and submit this. And you've seen that this also has been successfully submitted. So thank you very much for joining this session. And in this session, we have solved some really common problems. And this was just a stepping stone of what we've learned in the previous session. So in the previous session, we learned all of the basics of Python. So we worked with looping statements, flow control statements, and we work with basic data structures such as tuples, lists, dictionaries, and sets. And in this particular lecture or session, we learned how to combine all these together and solve some really common problems. So thank you very much for joining. And the next session will be covering object-oriented programming in Python. So again, if you really like these two sessions, do join us for the third session as well. So we'll be continuing these entire series till the next 2 weeks. So the live session link will be uploaded soon onto our YouTube channel. So do head there and also do attend the live session for the next class. And thank you very much. And I'll meet you in the next one.